Right now, as you are watching this, nearly 44 million people across the western and northern United States are under a heat advisory or an extreme heat warning, with forecasters saying Sunday could be the hottest day of the summer so far for Montana and North Dakota, where highs of 100 to 110 degrees are possible, as much as 25 degrees above what is normal for the middle of July. At the exact same time, in the mountains of Colorado, firefighters are still battling a wildfire that has already destroyed more than 850 structures, one that ignited during the same stretch of heat and dry lightning that has been baking the region for weeks. And in Missouri, rescue crews spent last weekend pulling hundreds of people out of floodwaters in the same general stretch of the country that had just spent days under a punishing heat dome. A woman named Faith Gregory was found dead in a creek near her home after floodwaters swept through. None of these. 3 things. The heat, the fire, and the flood are separate stories. They are the same story, and that is exactly the point scientists have been trying to get across all summer. The heat itself is rarely the most dangerous part of a heat dome. What comes after it, the dry lightning it sparks, the baked ground it leaves behind, and the flash floods that baked ground can no longer absorb, is very often worse. This is the story of what actually happens after a heat dome breaks, explained the way the scientists who study this pattern actually explain it, not the way a headline oversimplifies it. Drop a comment and tell me if the weather where you live has swung from brutal heat straight into flooding or storms this summer, because if it has, you have lived through exactly the pattern we are about to break down. I read every one of these. If you want grounded weather coverage explained through the actual science instead of recycled panic, subscribe. It is free. And a like helps this reach people who need to understand this pattern before it happens to them. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand why the aftermath of a heat dome can be more dangerous than the heat dome itself, you first have to understand what extreme heat actually does to the ground underneath it, because this is the part almost nobody explains, and it changes everything about what happens next. When soil bakes under high pressure and intense sun for days or weeks at a time, it does not simply dry out the way a sponge left in the sun dries out. In many cases, especially where vegetation has already been stressed or killed off, the surface layer of soil can develop what scientists call a hydrophobic crust, a water-repellent layer that behaves almost like pavement rather than dirt. Meteorologists studying this effect in Britain, after a punishing multi-day heat wave, demonstrated it using something as simple as a bucket of water poured onto dry, sun-baked grass, showing how a surface that should absorb rainfall instead lets it run straight off, exactly the way water runs off a driveway. One researcher from the University of Reading put it plainly, warning that the very rain a drought-stricken region desperately needs can become the thing that floods it, because heavy rain falling onto ground baked hard by a heat dome has nowhere to go but sideways, gathering speed and volume as it moves, rather than soaking in where it lands. This is precisely the mechanism that turned the collapse of this summer's first heat dome into a genuine flooding emergency, rather than simple relief from the heat. When that first heat dome finally broke at the start of July, meteorologists had been warning for days that the transition itself would come at a price, because the atmosphere trapped underneath the dome was loaded with moisture that had nowhere to go while the high pressure sat in place, and all of that moisture had to be wrung out somewhere. Once the block finally gave way. It gave way violently. More than 9 inches of rain fell in 24 hours just northwest of Des Moines, Iowa. Suburbs west of Chicago received 4 inches in a matter of hours. A significant flash flood event tore through the southwestern Chicago suburbs on the 4th of July itself, with rainfall rates measured at 3 to 4 inches per hour in some spots. A rate the ground, still baked hard from the preceding week of triple-digit heat, simply could not absorb fast enough to prevent street and creek flooding. The storms that broke that first heat dome ultimately knocked out power to more than 1.3 million homes and businesses and killed 4 people outright, on top of the roughly 25 deaths the heat itself had already caused in the days before. The second mechanism scientists point to is wildfire risk, and this one is even less intuitive because it involves the atmosphere producing lightning without producing the rain that is supposed to accompany it. During a heat dome, the atmosphere becomes what meteorologists describe as hot and unstable, conditions that are favorable for thunderstorm development even while overall humidity stays low. When those storms form, the rain falling from them can actually evaporate before it ever reaches the ground, a phenomenon known as dry lightning, because the lightning itself still reaches the surface, even though the moisture that should extinguish anything it ignites never does. A team of researchers who reviewed wildfire activity across the western United States between 2001 and 2024 found measurable increases in cloud-to-ground lightning, including this dry variety, during and immediately after heat waves specifically, and found that the risk of fire does not end when the heat dome itself moves on. Heat waves also strip away overnight humidity, meaning fires that do ignite can keep burning actively through the night instead of calming down the way fires normally do once the sun goes down. And the dead, dried out vegetation a heat dome leaves behind keeps that elevated fire risk alive for days or weeks after the temperatures themselves have already returned to normal. That is almost certainly part of the story behind the fire currently burning in Colorado's more than 850 structures, the vast majority of them homes, while crews continue fighting it under exactly the kind of dry, lightning-prone conditions this summer's heat has produced repeatedly. There's a third mechanism, and it is the one that connects fire and flood together into a single continuous hazard rather than two separate ones. Once a wildfire burns through an area, it leaves behind more than ash. Intense heat from a fire can bake the top layer of soil into the same kind of water, repellent crust a heat dome produces on its own, except more severe, because burning vegetation releases waxy compounds that seep into the soil and seal it even more tightly against water penetration. Scientists who study this effect in places like British Columbia, where wildfire seasons are frequently followed within months by catastrophic flooding, describe the resulting landscape as primed for disaster, because burned hillsides with no vegetation left to slow water down, sitting on top of soil that can no longer absorb it, turn even moderate rainfall into fast-moving floods and debris flows capable of sweeping away roads, homes, and people. This is why disaster. Researchers increasingly describe droughts, heat waves, wildfires, and floods not as four separate weather stories, but as a single connected chain where a warming baseline climate is directly parching vegetation and hardening soil in ways that make the fire that follows more likely, and directly setting up the flood that follows the fire, sometimes just weeks apart on the exact same patch of ground. Scientists have started calling this compounding pattern hydroclimate whiplash, and it is exactly why some of the most dangerous weather stories of this year have not been the heat records themselves, but the sudden transitions on either side of them. Severe to exceptional drought conditions across south-central Texas, for example, had already left soil across the region unable to absorb rainfall efficiently well before this month's flash flooding struck, a detail climate scientists specifically pointed to when explaining why relatively ordinary summer rainfall totals still produced flash flooding severe enough to sweep away roads and homes. The same underlying physics explains why New Orleans found itself with families wading through knee-deep water this month, even as extreme heat was simultaneously baking other parts of the same broader region, and why flood watches and extreme heat warnings have repeatedly been posted for overlapping parts of the country on the exact same day this summer, a combination that used to be considered unusual and is increasingly becoming the default pattern for how a heat dome actually ends. None of this is confined to any one part of the country either, as the second and now developing third heat domes of the summer have moved across different regions. The same whiplash pattern has followed each one. Missouri and the surrounding Ohio Valley states spent days under flood watches for Nashville, Lexington, and Charleston, even as extreme heat continued baking the Owais. Southwest, at the same time, a split that forecasters described as simply reflecting where the jet stream happened to be trapping air in place that week, rather than any coincidence. As this newest heat wave builds toward its peak this weekend, all-time high temperature records are being watched closely in Salt Lake City, Utah, and Billings, Montana, and forecasters are already warning that relief, when it finally comes late Sunday as a cooler air mass pushes in from the Pacific Northwest, will not simply lower the temperature quietly. It will very likely arrive the same way it has arrived every other time this summer, as a sharp transition capable of producing its own separate hazards, this time shifting the dangerous heat eastward into the northern plains and upper Midwest early next week, while the North American monsoon continues generating thunderstorms across southern Arizona and New Mexico. Storms forecasters have specifically flagged as carrying elevated flash flood risk in burn scar areas and slot canyons, the exact terrain where earlier fires have already primed the ground to fail against incoming rain. There is a slower, quieter version of the same compounding pattern that rarely makes headlines at all, and it plays out in agriculture and water supply rather than in a single dramatic flood or fire. Extended heat domes accelerate evaporation from reservoirs, irrigation canals, and topsoil alike, meaning a region can exit a heat dome technically still within its seasonal rainfall average on paper, while functionally deeper into drought than those numbers suggest, because so much of whatever moisture did fall during or after the heat evaporated again almost immediately in the heat that followed. Farmers dealing with crops already stressed by weeks of extreme heat then face a genuinely difficult choice when the rain scientists have been warning about finally arrives, because a hard, sudden downpour on baked, compacted soil is far less useful to a stressed crop than the same total rainfall spread gently over several days would be, since so much of it runs off rather than soaking down to the root zone where it is actually needed. Utility companies face a parallel version of the same whiplash, having spent the peak of the heat dome managing record-breaking electricity demand from air conditioning, only to then have to manage a completely different kind of grid stress within days, downed power lines, and flooded substations from the same storms that broke the heat, meaning the same crews and the different kinds of emergency back-to-back with little recovery time in between. So what does the actual data say about how much worse the after effects of a heat dome can be compared to the heat itself? And this is worth sitting with honestly rather than rounding up for effect. Heat alone, according to the National Weather Service's own tracking, killed 529 people across the country in 2024, more than floods, hurricane-force winds, and tornadoes combined for that same year, which already makes it the most underestimated killer in American weather. But when a heat dome's aftermath compounds into flash flooding, as it did over the July 4th weekend this year, the death toll accelerates, rather than resetting to zero once the heat itself breaks. The storms that ended the first heat dome of this summer killed 4 people through flooding and wind on top of the roughly 25 heat deaths that had already occurred in the preceding week, meaning the full toll of that single heat dome episode was closer to 30 deaths. Once its collapse, not just its peak, was counted, wildfire destruction adds a separate, slower-moving toll again, with Colorado's Aspen Acres fire alone destroying more than 850 structures, a number that reflects homes, livelihoods, and communities rather than a body count, but one that state officials have specifically tied to funding cuts affecting wildfire response capacity at agencies like the Bureau of Land Management, meaning the disaster's severity was shaped as much by preparedness and resourcing as by the weather pattern itself. So what does all of this actually mean for you, wherever you happen to be reading a heat advisory or a flood watch on your phone right now? The practical lesson scientists want people to take from this pattern is not that heat domes are becoming more frequent, though they are. It is that the moment a heat dome finally breaks is not the moment to relax. That transition period, the first heavy rain after a long, dry, hot stretch, the first thunderstorm rolling in after days of dry lightning risk, is statistically one of the more dangerous windows in the entire pattern, precisely because people instinctively treat falling temperatures and darkening skies as relief rather than as a new and different hazard requiring its own precautions. Treating a flash flood warning issued the week after a heat dome with the same seriousness as the heat advisory that preceded it, avoiding burn scars and canyon terrain during and immediately after monsoon, thunderstorms, and wildfire-prone regions, and understanding that a hardened, drought-stricken landscape can turn a normal rainstorm into a flash flood are all pieces of situational awareness that directly address the actual mechanism behind this compounding risk, rather than just the temperature number that made headlines the week before. Emergency managers who have watched this same sequence repeat itself in region after region this year have started pushing for something specific in response, treating the days immediately following a heat dome's collapse as their own distinct alert category rather than simply an afterthought once the heat advisory expires. Several of the flood watches issued across the Ohio Valley and the South this month were explicitly framed around the preceding weeks of heat and drought, rather than purely on forecast rainfall totals alone, a shift in how warnings are communicated that reflects growing recognition, even within the National Weather Service itself, that the danger window does not close the moment the thermometer drops. The honest, grounded summary is this: the extreme heat gripping large parts of North America this summer has never been a single isolated hazard, and treating it that way is exactly what leaves people unprepared for what typically follows it. Heat domes bake soil into a water-repellent crust that cannot absorb rain efficiently. They create hot, unstable atmospheric conditions capable of producing dry lightning that ignites wildfires, even without matching rainfall, and the fires and drought that heat leaves behind further. Harden the ground beneath them, setting up the flash floods and debris flows that so often follow within days or weeks. This summer has already lived out that exact sequence once, a heat dome through the end of June and the 4th of July holiday that killed roughly 25 people through heat alone, followed immediately by storms that killed 4 more and cut power to over 1 million. Homes, followed by a second heat dome that has already coincided with a Colorado wildfire destroying more than 850 structures and flash flooding in Missouri that claimed at least 1 more life. And as a third heat dome peaks across the northern plains this weekend, the same forecasters warning about record heat in Salt Lake City and Billings are simultaneously warning about flash flood risk in the exact burn scars and canyons that earlier fires this year have already left exposed. We are going to keep tracking this pattern exactly the way we tracked it today, straight from the National Weather Service, the researchers actually studying dry lightning and soil hydrophobicity, and the emergency management officials on the ground, not recycled panic headlines. Subscribe so you do not miss what this pattern does, as it shifts everything we just walked through. The collapse of this current heat dome is very unlikely to be quiet. And leave that comment below. Tell me whether the place you live has swung from extreme heat straight into flooding or fire risk this year, because if it has, you are not imagining a coincidence. You are watching the exact chain reaction scientists have been mapping out all summer. Because behind every one of these numbers is a woman named Faith Gregory, who did not survive a creek near her own home, a family in Colorado's high country watching more than 850 structures reduced to rubble by a fire that started in dry lightning nobody saw coming, and a city getting ready right now for a cool down that forecasters are warning could arrive as violently as the heat it is replacing. 5,000 likes on this one. Let us go. See you in the next one.